Hi. Do you remember that we used to solve equations for finding the unknown variables of x or y? Like for example, x plus y is equal to 4, x minus 2y is equal to 2. And this equations which are together in this system, when you analyze the system of equations, you gotta find the optimal point for which the two systems, the two equations are going to be satisfied. With these constraints, it is normal for when we gotta find the equations and as in kind of a very simpler equations. But what if the complexity increases? When the complexity increases, we have to go for computational method for making the solution making the solution to be known. So hence we use one of a Excel tool known as Solver for especially linear and non-linear equations. And for just a bit of revision, I will tell you about what is linear equations, what is non-linear equations. Linear equations. When you can understand about any equation which can be expressed in the form of a1 x1, a2 x2 plus so on, an xn plus b equals to 0. Any equation which can be expressed in such a form are now said to be linear equations. And any equation which is raised to the power of two higher order power such as a1 x1 squared plus a2 x2 plus so on equals to 0. These are to be nonlinear equations. We can say a system is having a linear set of equations when all the equations produced by the system are linear. We can say it is nonlinear and by at least one of the equation says that the system is nonlinear. So in general, you can understand from this glimpse how we used to calculate for the values of unknown variables for acquiring a particular solution for the system. But now, as computation is very important in order to search for large amount of numbers where the condition can be satisfied, we require to get the aspect of one of a tool known as Excel Solver, which helps us to find these unknown values and give us such as like unknown values or provide a solution for the system of equations, whether it is linear or non-linear. Now, so this session is about solver in Excel.
Okay, now let's get to know what the solver is and where it's located. Solver is a specialized tool which is primarily used to solve intricate problems by employing mathematical methods to find the best solution. It solves linear and nonlinear equations by using three types of methods: GRG Nonlinear, Simplex Linear Programming, Evolutionary. The GRG nonlinear and evolutionary methods are used for nonlinear equations, whereas the simplex linear programming is used for linear equations. So now let's go and see where in Excel the solver is located. This is our file, and if you just normally search for kind of a solver or search just for solver in general, solver, you cannot find over here as a kind of a software kind of a tool or something. You have to install it as an add-in. So for that you have to click on File, Options, and then here the add-ins. Then we have a solver add-in for inactive applications. In inactive applications add-in we have the solver add-in. We click on it, we select Go, and we select the solver add-in, and we're gonna say OK, so that it is going to be added. Here we're gonna see that it's being added something. So the solver is being added, and if you're gonna go for the Data tab, you can see the solver over here in the Analysis section. And let's open it. We said about the three methods which used to like calculate, right? Mathematical methods. So let's see, open and see where are the three methods. So here you set the solving method. There are three types of methods as discussed: GRG Nonlinear, Simplex Linear Programming, Evolutionary. These are the three methods. So let's get to go. Okay. So like we said about linear equations and nonlinear equations. So let's go and understand about linear equations. It is an equation that put in a form of a1x1 plus a2x2 plus so on plus anxn plus b equals to 0, where a1 to an and b are known as coefficients, x1 to xn are known as variables which are unknown. See, you do any equation which is in the form of this, like what are the features which we are having. The order is 1, the highest power, and is 1, and the highest power is 1. So variables which are unknown. The solutions of such an equation are values that when substituted for the unknowns make the equality true. So like when we kind of have, see, like as we discussed in an example, we gonna understand how linear equations gonna work. So linear equations occur frequently in all mathematics and their applications in physics and engineering, partly because nonlinear systems are often well approximated to linear equations. A system of linear equations is a collection of two or more linear equations involving the same variables. To solve a problem which are modeled with linear equations, we use the Simplex Linear Programming method. So let's get to a sample example of a problem. A company manufactures two types of products, product X1 and product X2. The profit from each unit of the product X1 is $3 and from X2 is $5. The company wants to maximize its profit. What is our objective here? To maximize our profit. But it is constrained by the following resources. These are the constraints: resource 1 and resource 2. To read the resource 1, each unit of product X1 uses 2 units of resource 1 and product X2 uses 3 units of resource 1, and the total available units are 12. And when it comes to resource 2, each unit of product X1 uses 2 units of resource 2 and product X2 uses 1 unit of resource 2. Total available are 8 units. The company needs to decide how many units of product X1 and product X2 to produce to maximize profit while not exceeding resource limits. So let's go here. So we have to objectify the profit. Here we have an X1 or X2 products. Here is the number of units, X1 and number of units and X2 number of units. So which has to be find by us. So like let us write the objective function is equals to, we from X1 product we are getting the $3 profit. So 3 times of each unit plus, and X2 we are getting the $5 profit, 5 times of each unit of X2. These are our objective function. And let us define the constraint. The first thing in the resource 1, and this is resource 2. Okay. So we know from that actually we understood there is a kind of a constraint. How many units of product X1 uses? Let's get to the question. Each unit of product X1 uses 2 units of resource 1 and product X2 uses 3 units of resource 2. Then it is like 2 into number of X1 and 3 into X2, number of units of X2. So it's gonna be like equals to 2 into number of units of X1 plus 3 into number of units of X2. And it is also said that their only total resource constraint is 12. The constraint is 12, so it should be like we can only have a less than or equal to 12. And whereas coming to, let's focus on resource 2 constraint. Each unit of product X1 uses 2 units and product S2 uses 1 unit. So this says that 2 into equals to 2 into number of units of X1 plus 1 into number of units of X2, which is less than or equal to total number of units, which are 8. So we have noted all the constraints and values of constraint, and objective function also was set here. So now let us make this objective function maximize. So let's go to solver. You gotta set the objective Z10. The cell, it's not Z10, is it H2, and we are going to maximize it, maximize the profit. Objective is to maximize the profit, and by changing the variable cells, the X1 and X2 units, as subject to constraints. Constraint 1 less than or equal to 12, add constraint 2 less than or equal to 8. And there is also something, resources cannot be negative, so we can also add this kind of stuff. Add X1 greater than or equal to 0, add X2 greater than or equal to 0. Now click on OK. We gave the constraints. We set the objective function to maximize by changing variables and every details. And here this make unchanged variables non-negative. This depends on the question you are solving, so it is not a problem to leave it as well, but when the question has it, you have to definitely uncheck it. So we are using the algorithm known as Simplex LP, Simplex Linear Programming Algorithm. So and we are solving it. We got a result over here. You're gonna see that the maximum profit we can get is 20, and the number of units of X1 is 0, number of units of X2 is 4, which is required to produce for achieving this profit, and resource 1 is utilized optimally, whereas resource 2 is only used of 4 units of resource 2, rather than when we have 8 units of resource 2. So let us go here. Here you can get the 3 types of reports actually: answer, sensitivity, limits. These are the 3 reports which are generated. Let's click on OK so that we can go and understand the reports. Okay. Yes, now the reports all got generated as a separate sheets beside the Simplex Linear Programming sheet. You can go for answer report 1, and you can read all this stuff. And objective cells was to profit. The original value was 0. There is no value. The final value is 20. The variable cells, the X1 and X2, the original value is everything is like just empty, and final value 0 and 4. And coming to the constraint, we gonna have resource 1 constraint is 12, less than or equal to 12, and it is having 0 slack. We are used all resources, so that's why we are having a 0 slack in it. But whereas it's also a binding, because any change, binding is help us to be careful that any change in this kind of a constraint will affect the entire equation, and the values will affect the values of X1 and X2. And coming to resource 2 constraints, we do have here, we're using 4 units of resource 2 constraints, which is not binding, and we have a slack of still remaining 4 units of units are still remaining of resource 2. And unit X1 it is 0, which is binding, because it is slack is 0, because the reason is that if there is a change in variation of this constraint, then definitely it's going to be affected. That's why it's binding. Whereas unit X2 was not binding. So now let's get to the other 2 reports, sensitivity and limits report. Sensitivity report. If you're gonna go at sensitivity report, you're gonna check that why we really didn't calculate the value of X1. We didn't really care of, because that's why it's represented as 0. But when we gonna care, the objective coefficient of that final is 3. And 3, that the reduced cost is minus 0.33. So like if the X1 gonna be varied as this much kind of a vary is there, then definitely it is going to be considered for finding the unknown values. That's what it is saying, reduced cost. And you can find this in the definition which I am going to provide. Reduced cost and the shadow price. And coming to the constraints, we gonna have said the final value is 12 and a 4. And constraint right hand side is 12 and 8. So here it says that each unit of increase in the right hand constraint will affect the profit by this much of the amount, that is much of the price. That's what it is saying. So and that's what sensitivity report helps us to know, that the importance of a particular coefficient and a particular right hand side constraint which can affect the entire solution. That's what it says. And coming to the limits report 1, you can get the lower and upper limit of both the things. Lower limit is when the objective result is this, the upper limit when the objective result is this. This is the way you can get the answers of Simplex Linear Programming in Simplex Linear Programming. Now let's get to the next kind of a method known as for nonlinear equations, which is known as GRG linear. So let us know what is nonlinear equations. Nonlinear equations contains polynomials, so made of many variables with quadratic, cubic and higher order terms, as well as rational, exponential and logarithmic functions. It appears as curved lines when graphed and can take many shapes. A system of nonlinear equations is where one of the equation is not linear. One of the method we can use to solve the equations is with generalized reduced gradient nonlinear. It is specifically designed for tackling problems that involve smooth nonlinear functions. Once remember that it is important that we have to tackle for smooth nonlinear functions. The solver method looks at the gradient or slope of the objective function as the decision variable changes and determines that it has reached an optimum solution when the partial derivatives equal 0. The derivatives which it uses are of two kinds: forward derivatives and central derivatives. Forward derivatives, useful for faster calculations when the problem is not highly sensitive to precision or when the function is relatively smooth. This is a formula for forward derivative: f of x plus h minus f of x by h. And central derivatives, better for problems requiring higher accuracy or when the function has significant curvature or irregularities: f of x plus h minus f of x minus h by 2h. So when using this, it starts from a single point of initial condition. Hence may find that the solution is, and may think that the solution is optimal. To get off from this error, we use multi-point, which is multi-start. The algorithm creates a randomly distributed population of initial values that are each evaluated using the traditional GRG nonlinear algorithm. By starting multiple times from different initial conditions, there is a much greater chance that the solution found is the global optimum. Now here let us so we understood what is GRG nonlinear method, and we can let us get to understand it better by solving this problem. You are managing a production facility and you want to determine the optimal values of two variables x and y to maximize revenue subject to the following nonlinear constraints. So we are here to maximize the revenue. Let's put this equation on the kind of a thing. Here x values and y values. Here the unit value of x and y is going to be entered, and here is revenue which is going to be entered, equals to 5 into x plus 7 into y plus 7 into y plus minus 0.5 x square minus 0.3 y square minus 0.5 into x square minus 0.3 into y square. This is what our revenue function expression is, or we can also say function. And let us write the constraints here. The constraints for x and y: x square 5, so y square less or equal to 25. Let's write the constraint equals to x square plus y square less than or equal to 25. And x plus y is less than or equal to 10. X plus y less than or equal to 10. X is greater than 0 and y is greater than or equal to 0. Both are non-negative. X is greater than or equal to 0 and y is greater than or equal to 0. So we entered all the constraints and we entered the revenue function also, revenue formula also here. Let's get to the data, let's get to the solver. And now we are here to maximize the revenue. We have selected the cell Z2 and we require to maximize it, and we are selecting the variable cells which can be changed, variable cells, and let's add the constraints now. Cell reference less than or equal to 25. Add cell reference less than or equal to 10. Add x greater than or equal to 0. Add y greater than or equal to 0 and click on OK, because we added all the 4 constraints. Click on OK, and we got here GRG Nonlinear. And after selecting GRG Nonlinear, get to the options over here. So to make initial setting of parameters. So let's go to GRG Nonlinear. Here convergence, which is something 0.0001. That much in the H which is really required with careful scrutiny. And we have 2 derivatives, forward derivatives and central derivatives. As we discussed, forward derivatives are going to be used when we doesn't really require to find an optimal value with accuracy, whereas central derivatives are used for finding it with high accuracy. So let's go for using central derivative. And for multi-start, let us use a multi-start, because when we have started from a single point, it may end it to some wrong solution, that with maybe a gradient, because it's derivative, maybe it or may not be it. But if you use multi-start, it starts from a different points at the same time, so that the process of finding the solution is going to be very better. And population seed is 100 and a random seed is 0. We can also give any random number, but it is very important to give this number, because this random seed helps to get the same set of outputs to find, and require bounds on variables. This is not required, so because we only have greater than or equal to 0, it is not required, and we are unchecking it off, and we are selecting of OK. And now after selecting this, we select the algorithm, and now we are here to solve the thing, so that we get a solution which satisfy all these constraints and maximizes the revenue. The revenue which is generated is 34.06123 with this x and y values respectively. So you can click on answer and you can say OK, so that report is being generated. And here is the answer report. Here is the solver engine. Engine is GRG Nonlinear, and solution time it took about 0.422 seconds. Iterations are 0, subproblems are 2. Solver options. These are the options which we have selected for the solver. And objectives as revenue. First in the initially it is 0 and the final value is 34.06, and the variables also initially it is 0, and by selecting this particular values of x and y, you will get a revenue profit of the maximum revenue of this much. And this is our constraint, and we can see here which is binding and which is not binding. Binding are the bindings, as we already discussed in the simplex linear programming. The binding is something which is very important values which we have to consider, and slack is also one of the important values which has to be considered. So we discussed about 2 algorithms over here. So but there is only one other algorithm, one other method. The another method to solve nonlinear equations in the solver is evolutionary. The evolutionary method is suited for non-smooth or discontinuous problems. Like derivatives can only work for the continuous equations, but this evolutionary method is suited for non-smooth or discontinuous problems, which are generally the most challenging type of optimization problems to solve. Determining the direction in which a function is increasing or decreasing becomes difficult, and thus evolutionary method is tailored to handle this complex optimization problems. The evolutionary method is based on theory of natural selection. In simple terms, the solver starts with a random population of sets of input values. These sets of input values are plugged into the model, and the results are evaluated relative to the target value. The sets of input values that resulted in a solution that closest to the target value are selected to create a second population of offspring. The offspring are a mutation of the best set of input values from the first population. This goes on until there is a very little change in the objective function. So by solving the example we can understand it better. So let's get to our Excel. Excel file, GRG Nonlinear, and this is our evolutionary. It's over here. So first of all, generally we used to add the first of all the kind of an objective function. Here here in this method actually we need to find the x and y such that the error is minimum. So let us write the constraints. X square plus y square equals to 25. This is our one of our constraint. So we can here write our x square plus y square should be equals to 25. And there is also one more other constraint. X into y equals to 12. X into y equals to 12. These are all the four constraints which we have. Here we have to minimize the error. So let's make it real. So that's why we gonna find the absolute value of, so as it is a minimization of error function, absolute value of first constraint plus absolute value of second constraint. And now we are here to minimize the error. So we're gonna click on error, we're gonna click on solver, and we select the kind of set the objective, and the objective is to minimize the error by changing the variable cells. These are the two, but subject to constraint. Let's add the constraints. Cell reference equals to 25. Add cell reference equals to 12. Now click on OK as we added both of the constraints. And there is one, I cannot tell you the bounded variables and unbounded in a few minutes. Let us solve with whatever the required things which we have. Let us solve this equation. GRG nonlinear to evolutionary. And if you're gonna go to the options, you're gonna see here in the evolutionary section the convergence is about this, and the mutation rate, the population size is 100, the random seed which is 0, and I'm gonna give the random seed of 4. Maximum time without improvement is 30 seconds. Require bound on variables, so we can uncheck this. And now as we have no bounds regarding this, so now if you are gonna click on OK, and if you're gonna click on solve, you don't see that's a problem, trial solution and objective solution. It goes as the second method how we have explained it, goes as with a lot of set of values, changing the values, tweaking the values, and gives us the optimal solution. It's going on, like sometimes. That is why if the objectives are doesn't really changes the kind of it will be stopped after 30 seconds. That's why as is the principle based on the principle of natural selection. That's why we need to be very careful. So you're gonna see that solver cannot find a point for which all constraints are satisfied. So so that is what the answer was. But now let us write the constraints which are bounding in nature, such that x should be this kind of solve. Let's get a solver. Minimum value by changing the variable cells. Let's add. This x1 should be less than or equal to 10, whereas x2 y, which is x2, is also less than or equal to 10. So we are bounding the variables now. Click on OK, and we're gonna go select for options and evolutionary, require bound on variables. Select OK, and now solve it. It goes in the kind of a way. Now the objective cell error is about 29.92. We have to minimize it further, and the system is checking to minimize it further. You're gonna see that the decrease of this value. Solver cannot find a point for which all constraints are satisfied. So okay, but it may not find a problem which is said, but it's already gonna give us an answer. Solver solutions having constraints this much, okay, and let's try to click on answer and population. By this kind of thing, it found that this is an answer for optimal answer solution for this answer. So let's go to answer and population over here, and we can generate the report set. If you're gonna go for check the answer report, you're gonna see that error is in the original value is 0 and the final value is 29.90114783. So this kind of an error which we have. And coming to the variable cells, it is selected the final value as 3.124792777 3.189224431, and we have a constraints which are binding and non-binding constraints, which is also very important. So let's get to the population report as the thing which is based on random selection population. So we have to understand it's better to get the distribution of values of x and y, how it really checked. It choose the best value of this much. It checked whatever all it calculated. It calculated the average value. It calculated the standard deviation among those, with the mean value to the best value and the maximum value and the minimum value. In the same way, it calculated for both x and y constraint and for y variables, and in the same way it had it for the constraints also in the same manner. So I'm going to try once more with a few other tweaks into this, because this is an error 29.90, which is a very high in nature. So let me try to take it very minimal. Let us try to take it as a minimal thing. Convergence, let's make the convergence of population size, which one has to be tweaked. Okay, that's the, okay. Okay, that's how we can use all these three methods, GRG Nonlinear, Simplex Linear Programming, and Evolutionary three methods for solving the equations or expressions in the using solver.
Okay, that's how you can find the solutions for the system of equations, which can be either linear or non-linear, by using Excel solver. I'm hoping that you are going to use this tool of Excel for further when calculating calculating to find the solutions of for system of equations.